And I don't know if it's symmetric. It's so small. Who knows whether it came from a symmetric distribution or not. So we're going to use this small data set to show you how to find the standard deviation by hand. Okay? So first off, find the mean of 3, 5, 7, 10, 13. $7.6. Thank you. All right. Thank you. All right, we're verified now. The standard deviation is going to be the measure of spread that we're going to use for the mean, and it is, and remember this definition, the average distance each value is from the mean. So the standard deviation is going to be the average distance that 3 is from the mean, 5 is from the mean, 7 is from the mean, 10 is from the mean, 13 is from the mean. And I put the word average in quotation marks because it's not going to be a plain old average. So let's see if we just found the average distance each one of these values was from the mean. Well, 3 is 4.6 less than the mean. 5 is 2.6 less than the mean. 7 is 0.6 less than the mean. 10 is 2.4 greater than the mean. And 13 is 5.4 greater than the mean. Let's find the average of all those numbers. Add them up together, divide by 5. Those are called the those are called the deviations from the mean. Not the standard deviations, but the just plain old deviations from the mean. Okay, we've got, so far I think we've gotten 8 different numbers from 8 different peoples. But I heard what it was the first person that got it. 0. 0. Can you use a calculator? Okay. Good job. Oh, didn't throw in the, and those are the absolute deviations from the mean, and we could talk about those if we wanted to. We do the standard deviations from the mean. Okay. If I just looked at the average of the distances from the mean, sign differences from the mean, I get 0. So that's not going to be, that's always going to be 0. That's not going to be a particularly good measure. My measure of spread would always be 0. So let's not use that one. That one doesn't make a whole bunch of sense. So instead, we're going to use something that has some square roots in it, some squaring, blah, 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 blah. Okay. So the standard deviation formula is going to be a square root of the sums of the difference, each point is from the mean, squared, divided by the number of numbers in our set minus 1. So calculator's out. Let's do this step by step. So I take each number. So that's 3. I subtract 7.6. Was that my mean? And square it. And add it to 5 minus 7.6. And square it. And add this to 7. Minus 7.6. Square it. By the time I get this written, you should have an answer for me. 10 minus 7.6 squared plus 13 minus 7.6 squared. I need an answer for this sum. 63.2. Okay? Now I take that sum and I divide it by 5 numbers minus 1, 4. So 63.2 divided by 4 is how much? 15.8. This number has a special meaning. This number is called the variance. and it is abbreviated S squared. Okay? But I don't want the variance, I don't want S squared, I want that S there. So now to find my standard deviation, and I'll abbreviate that STDDEV, is the square root of the variance, which is the square root of 15.8, which is 3.97, which means on average my values have a distance of 3.7 from the mean. 3.97, sorry. Okay, so that's what my standard deviation tells me. On average, the values differ from the mean by 3.97 units. Okay? This number also exists in your calculator. See if you can find it. See? Jack, run. I don't know. So you can find this number in your calculator with 1var stats. So why don't you throw those numbers, the 3, 5, 7, 10, 13? So the reason you have to know how to do this is because sometimes on the AP exam, they have asked you to calculate standard deviation by hand for a very small set of numbers, but they did. You can, but you have to show what you did. Well, 3, 5, 7, 10, 13. Sorry. Okay. So I have mine in list 1. I'll hit Stat, Calc, 1var stats again, and hit enter because I was in list 1, and that 3.97 is right there under the SX number. Okay, so the number below it is sigma x. It is also the standard deviation, but it is the standard deviation if we had divided by n instead of n minus 1. If we had divided by 5 instead of 4, we would have gotten to 3.55. And that's called the population standard deviation. If we thought we didn't have a sample, we'd use that one, but mostly we have samples, and so we use the sample standard deviation. The sample standard deviation divides by n minus 1 by 4 instead of 5 in this case, because we have what's called 4 degrees of freedom. And we divide by the number of degrees of freedom, which is a topic we don't have to cover, but we can if you guys want.